folks, welcome to numbers 13 and 14. So much like the previous examples, I've got these rational equations. I'm going to find some LCDs, multiply every term by the LCDs, and then get rid of the fractions. And one thing to note is this fraction down here in number 14, I can see the GCF. So I'll just keep that in mind when I build the LCD. So here, if we look at 13, I've got a denominator of 1, essentially 3x and 3x, so my LCD will be 3x. I'll keep that in mind. Here, again, I've got a denominator of 1, x plus 2, and then x. So if I want to build my LCD, I need the factor of x represented, and I need x plus 2 represented. And I'll take the highest exponents either of these factors have, but they're all raised to the first power. So I'm just going to have my LCD with those two factors of x and x plus 2 raised to the first power as well. Okay, so I'm going to erase my little LCD work because this gets really tight. I don't have a ton of space. And then I'm going to go ahead and multiply every term in both equations by their respective LCDs. And let's see what cancels. But I'm going to do 13 first. So I'm going to start over here on the left just to give myself some space. So 3x times 1 plus 3x times, it looks like this trinomial of x squared minus 5x minus 24 over 3x. And that should be equal to 3x times x minus 6 over 3x. 3x's are going to cancel here and here. So it looks like we have 3x plus x squared minus 5x minus 24. That's going to be equal to x minus 6. So let's just start to collect some like terms. So on this left side, I've got an x squared. Positive 3x minus 5x is minus 2x minus 24. That should be equal to x minus 6. I'm going to subtract x from both sides, and at the same time, I'm going to add 6 to both sides because I have a quadratic equation. So I can either, I can either factor that or use the quadratic formula, but in both of those cases, I need to have a 0 on one side of the equation. So these cancel by design. That gets me that 0. I'm going to have x squared minus 3x, negative 24 plus 6 is minus 18. So there's my quadratic equation. If you prefer the quadratic formula, no problem. A is 1, B is negative 3, C is negative 18. I'm going to factor, because I can think of two numbers that multiply to negative 18, but add to negative 3. So it would be negative 6 and positive 3. Right? Because negative 6 times positive 3 is negative 18, but negative 6 plus positive 3 is negative 3. And so when I get out of that, I have the zero product property. So either x minus 6 is 0 or x plus 3 is 0. So I'm going to get x is 6 or negative 3. And neither of those answers will result in the denominator being 0. So I'm going to keep both of them. Okay. So same thing's going to happen over here. And let me put a little separation bar. So I'm going to do x plus 2 times 1. That will be equal to x plus 2 times this fraction. And I'm going to rewrite this denominator factored out. And then I'm going to have x plus 2. And then we've got x minus 1 over x. All right, so cancel, 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 cancel. And then let's see what we have left. So I have here x times x plus 2. And times 1, but I'm going to distribute. This is going to be x squared plus 2x, right? X times x squared, x times 2, 2x. All right, this LCD completely canceled with this denominator, so I get a 1. Here I have a binomial and a binomial, right? I'm going to be adding x plus 2, x minus 1. So I'm going to go ahead and distribute this on the right side. So x squared plus 2x is going to be equal to 1 plus, okay, first is x squared, outer is minus x, inner is plus 2x, and last is minus 2. So let me go ahead and clean that up a little bit. Let's see what we have here. On the left side, I have x squared plus 2x. On the right side, I do have that x squared term. Okay, I have minus x plus 2x, so that's going to be plus x. And then I have plus 1 minus 2, so I believe I'm going to have minus 1. All right, and then when I start to clean this up just a bit, let's see what we have. I have an x squared here, x squared here. I'm going to subtract the x squareds from both sides. All right, I'm gonna subtract a 2x from both sides. And let's see how this is playing out. This cancels, that gives me a 0. This cancels. X minus 2x is negative x minus 1. Okay, so that actually got me to a linear equation. If I have a linear equation and we have the x's on one side, the constants on the other, so now I'm actually just gonna add the x back to this side. And when I simplify that a little bit, let me move this over here, I'm gonna get x equaling negative 1. And x equaling negative 1 is a totally fine number to plug into any of those denominators. So I'm gonna keep that as my answer. All right, thanks so much. Bye.